Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Well, guys, today my topic is the speed time graph or the velocity time graph. As I told you that in the case of the speed time graph or the velocity time graph, both the graphs are drawn in the same way. There is no difference in drawing these two graphs. Well, first of all, I'm going to discuss that when the body is at rest, I'm taking speed mentioned with V meter per second and the time in seconds. Okay. When in the speed time graph, when you are going to mention that the body is at rest, so you will have to mention a line at the bottom at the zero. Okay, because this zero is mentioning that the velocity is zero and the time is passing, because if you are moving on this line, the time is going on, but velocity is zero. So this is showing that the body is at rest. Okay. Well, now the second thing, the body moving with constant speed or constant velocity or uniform velocity, it mean it is moving, a horizontal line will be shown. As you know that when the velocity is not changing or speed is not changing, then acceleration will be zero. As I told you that here we are not considering the direction. So remember this, while looking at the graph, we have to decide from the line of the graph only. From the line of the graph, we have to decide that whether the velocity is uniform or not. Here, this horizontal line is showing that the velocity of the body is uniform, whatever the value of the velocity may be at this instant, so that value will be taken. When we are studying the speed time graph or the velocity time graph, one very important thing, that the gradient of this velocity time graph gives you the acceleration. Here I have written that acceleration of the velocity time graph gives you the gradient, and the distance or displacement can be calculated by area under the graph. This I'll explain you, inshallah, during the course of this lecture, inshallah. Okay, now, first of all, as I told you, that the gradient or the slope of this line gives you the acceleration. Okay, remember this fact. So here you can see that this is a horizontal line. As you know that if the line is horizontal, then its gradient is zero, so acceleration will be zero. It must be clear to you. So because velocity is uniform, acceleration is zero. Now third thing, speed or velocity constantly increasing. Here, its straight line going in upward direction is showing that the speed or velocity is constantly increasing. There is a uniform increase in velocity or speed. So whenever the velocity is increasing uniformly, obviously, if you are going to find out the gradient of a straight line or the slope of this straight line, it will be the same throughout the length of the line. So this shows that uniform acceleration, that acceleration is uniform. Okay. Now the fourth case, here I have shown you with a straight line that the velocity or the speed is decreasing. When the velocity or speed is decreasing, even then there is acceleration, but that acceleration is termed as negative acceleration, and you know better that negative acceleration is called deceleration, because velocity is decreasing constantly. This straight line is showing that the velocity is decreasing constantly. There is a constant decrease in velocity, so we will say that there is uniform deceleration. Okay. Now there is a fifth point. This curve is showing you this. If this curve is smooth, then it will show that the speed or velocity non-uniformly increasing. This curve is showing in upward direction, so it is an increasing trend in the velocity, but non-uniform increase in velocity. As you know that when the velocity or speed is non-uniformly increasing, there will be a non-uniform acceleration. Okay. In the same way, if the velocity is decreasing non-uniformly, velocity or speed is decreasing non-uniformly, then this shows This also shows that non-uniform deceleration. These are the explanation. Okay. Well, here you can see that I have shown two graphs. One graph is showing this curve. This is also increasing speed or increasing velocity. This is also increasing speed or increasing velocity. Both are showing you increasing speed or increasing velocity. But what makes the difference here? We have to consider that difference. As you know that I told you that the gradient or slope of the velocity time graph gives you the acceleration. You know it better. The gradient or slope of the velocity time graph gives you the acceleration. Now you can see that this curve is going in upward direction. This is also going in upward direction. Both are the graphs of increasing speed. As you know that if you are going in upward direction, the speed is also increasing. If it is going in right side, the time is with the span of the time is also passing and the speed is also increasing. Here is also you can see that time is passing, that speed is also increasing. Okay. Now I'll tell you that this is an increasing acceleration, but this is decreasing acceleration. How you will decide that this is increasing acceleration, this is decreasing acceleration? As I told you, this will be decided from the slope of the graph. Now here I am taking a point A. Suppose this is the point A. I am going to draw the slope of the graph or the gradient of the graph at point A with the help of the ruler. Yesterday, during the last lesson, I told you that this is the tangent line which must touch the curve at a single point. I am drawing this tangent line. Now you can see that the slope or gradient can be calculated with the help of this tangent line. If you will find out the slope of this tangent line, then you can find out the acceleration at this point A. This will be the acceleration at point A, not the acceleration throughout the curve, because as I told you that it is the non-uniform acceleration. This is also non-uniform acceleration, non-uniform acceleration. These both cases are the cases of non-uniform acceleration. Now, as I told you that at point A, the slope of this straight line gives you the acceleration at this point. Now, if I take another point on the slope, I'm taking another point on the slope. Now, again, I am going to draw another tangent line. Okay. Now here I am giving the slope of A at M1 as M1. This slope I am naming as M2. Now you can see that which line is steeper. Which line is steeper? M1 is steeper or M2 is steeper? Okay, B is steeper. It is obvious. This is lesser steeper. This is more steeper. As I told you that the gradient of this line gives you the acceleration. So here the acceleration is lesser, here the acceleration is greater. And if you are choosing another point here, say I am choosing another point C at this instance, now again I am going to draw another tangent line. So this tangent line will gives you the, this is, say this tangent is M3, so it is more steeper than the rest of the two lines. Okay, so M3 is the more steeper. So here you can watch the trend of increasing acceleration. Here the acceleration was lesser, now more steeper, more steeper. It means acceleration is increasing when you are going with the curve like this. Now, in the same way, please concentrate here. The same thing I am doing here also. Say I am taking a point, I'm taking a point uh, E, D. Say here I am taking a point E. Now I am going to draw a tangent to the curve. This, say this is M4. I am taking this tangent as M4. Now it is steeper line. Now here I am taking another point, which is point E. Now at point E, you will have to draw another tangent. Now from D and E, it is obvious that the line M4 or the gradient M4 is more than the gradient at E. So this sorry, this is M5. I must say this is M5. Okay, this M5 is greater than M4 because it is more, it is, sorry, it is less steeper. This M4 was more steeper, but M5 is less steeper. Now, if I'm going here, say A, D, E, F, I'm taking an F point. Here I can draw another tangent. So this tangent, say it is M6. So you can observe that the tangent, the value of the tangent is decreasing as we are going with the curve in upward direction. So that is why, as you know, that the tangent of this straight line gives you the acceleration. So acceleration is also decreasing. So this is the case of decreasing acceleration. Okay, now I'm going to tell you, as in the in this page, I told you that the distance or displacement can be calculated by area under the graph. Now this idea will be explained, that how the area under the graph gives you the distance or displacement. Let me tell you an example with the help of an example, because here I will have to draw a very simple graph that how I am going to find out the distance traveled by the body during the given time. For example, first of all, I am going to draw a simple graph like this. This is velocity, this is time. Remember this labeling is very important, like velocity and time. Its units are also very important. Whatever the unit you are using, whether you are using kilometer per hour, you must write I'm using meter per second and time for second. So whatever the unit are required in the examination, you will have to see. Well, now what I'm going to discuss, I'm going to discuss that area under the graph gives you the distance traveled, area under the speed time graph or the velocity time graph. Remember this is speed time or velocity time graph, so that you must not be confused that we are talking about speed time and velocity time graph. Okay, for example, if I am going to draw this line, say this is the line. Suppose this is the line of which type of velocity is shown. Can you tell me? It suppose at this point it is 25, and the time at this instant is 5, 10, say it is 15. Okay, well, now what type of what whether the uniform velocity or varying velocity? Constant speed, very good. So this graph is showing you that constant speed. When the speed is constant, it means acceleration is equal to 0. So you have understood. Now area under the graph. Actually, if someone asks you find distance or displacement, find distance, find distance for 10 seconds. Okay, so distance covered during the first 10 seconds. So what we have to do, we have to draw like this, because this is a horizontal line. You have to draw a vertical line like this. So if it is required, this I'm just giving you an example, that for example, if someone asks you that find out the distance for the 10 seconds, so from 10 seconds you will have to draw this line, and this area will be calculated, this area under this line. This is the graph of the speed now. So under this graph till 10 second, you have to measure the area. Now you can see that what is the shape, what is the shape here, what shape you can see. I hope that you understand the shapes. Okay, so you can see that this shape is a rectangle. Very good, bacha. So this shape is a rectangle. So obviously to find out the area, you will have to find out the to find out the distance or displacement, you will have to find out the area. So distance or displacement, whatever it is required, length multiplied by breadth. This is 25 and this is 10. 25 multiplied by 10 to 50. Here remember this, because we are going to find out the distance with the help of the velocity time graph. So here we are not concerned with the units of area. Here we are not going to apply the units of area. Here we are going to apply the unit of distance, because the velocity is given in meter per second and the time in second. From here you can see that if the velocity is given in meters per second, so the unit for distance will be meter. If it were be kilometer per hour, then the unit for distance will be kilometer. Now let us have another example. Okay, I am going to draw another graph for the sake of convenience. For your better understanding, I am drawing another graph. Here, velocity in meter per second and the time in seconds. Here I am going to draw a line like this. First of all, the body is accelerating. Say it is only this line. Okay. And suppose under this line, the time is say 8 seconds. And this is the velocity which is given. Suppose it is 30, okay, meter per second. Okay, whatever the unit I have mentioned on the graph. So this, so 8 second and 30 meter per second. Now you have to observe that under this line, under this line, under the shadow of this line, this is an X, this is a triangle. So to find out the distance, if somebody asks you that find out the distance for the 8 second, if somebody asks you that find out the distance for the 8 seconds, distance for 8 seconds, if somebody asks you, so what you are going to do, distance or displacement is equal to area of triangle. You know the formula for area of triangle, half into base. The base is 8 second and the height is 30. Half into base into height, this one, because whatever the shape can be seen, you will have to apply the formula of that shape to find out the area of the shape. But remember this, you are not going to apply the unit of area, you are going to apply the unit of distance, because you are going to find out distance. So you can divide 8 by 2 or 30 by 2, it's up to you. I'm dividing 8 by 2, so 120 meters. Okay, this is a very simple example. I'm going to give you another example, example in which I'll make more than one sentence. I would like to tell you that how we are going to find out if you have a complex figure like this, which I am going to draw, because it is also very important to understand this factor. This is velocity, which is meter per second, and the time, which is given in seconds. Here, suppose you people are given with this type of graph. I'm going to make a complex type figure, and then this. For example, this is the time 5 seconds. Now this is say 10 seconds. Now here the time is 13 seconds. Okay, and the velocity or speed at this instant is, suppose it is 20. Okay, now what we have to do, we have to find out the total distance, whatever the distance is required. For example, if he asks you that find out a distance for the 5 seconds, then you will have to find out the area under this graph only, because this is accelerating body. Sometimes he can say you find out the distance during the first 10 seconds. So you will have to take this total area, triangle, plus this rectangle or square, whatever it is. It depends upon these sides, whether it is square or rectangle. It's up to you that what the mm, uh, uh, constants are written here. Okay, if we ask you that find out the total area from very beginning from 0 till 13, then obviously you can find out the area of triangle, then rectangle, then again this triangle, or you can simply find out the area of this complete trapezium. It's up to you, whatever you find it easier, so you can find out. Okay, if you know that what is the area of trapezium, you can just apply the formula for the area of trapezium. The This side of the trapezium is 13 and this side of the trapezium is 5, because this side is 5. Now I am going to find out the total distance traveled. Total distance or displacement. Total distance or displacement is equal to half into sum of parallel sides. This side is 13 and the other side is 5, into the height. The height is 20. So I applied this formula. 2 ones are 2, 2 tens are 20, 13 plus 5 gives you 18 and 180 meters. So here you can see that I have found out the distance traveled with the help of the area under the graph. To find out the total distance, I'm taking total distance. So total distance from 0 till 13 seconds, it is 180 meters. I hope that you have understood this. Now let me um, very good. I know that Mind Fatma, you are always present, inshallah. Will you upload worksheet today? Yes, inshallah. Today I'll upload the worksheets, inshallah. Those who have understood, thank you so much. Thank you for the compliment, sir. How will we know where to put the upper line? Which actually here I have given you an example. Somebody is asking me that how to put the upper line. Actually, I have given you an example of a speed time graph. If this type of graph is given, for example, during the last few minutes, let me give you another example, and I'll ask you that what is the distance traveled. Okay, well, for example, just in 2 minutes, I can explain this again, inshallah. So here you have the speed in meter per second or time in seconds. I'm going to draw. If you people are given like this, and this is the speed, which is, say it is 60, and here the time is 20, and this is 25. Now if I ask you that what is the distance traveled during 20 seconds, what will be your answer? Please tell me the distance traveled during the first 20 seconds. Seeking your answers. Okay, very good. Okay, somebody has given me very large answer and somebody has very small answer. Okay, I think so. One student has not calculated well. Otherwise, the rest of the students are giving me correct answers. Okay. Um, well, as I told you that here we are not going to write down the area unit because this is a rectangle. We have to find out the area of rectangle. If this is asked, let's find out the distance for the first 20 meters. Then 60 into 20 gives you 112 meters. And if somebody asks you that find out the total distance, so you can find out the area of rectangle plus area of triangle, or you can find out the area of trapezium. I hope that this is clear to you. Next time, inshallah, I'll also do some more things related to the same. Okay, in which inshallah I'll discuss the graphs. In addition to graph, I would like to do some practical work also, in which we'll try to find out the diameter of a wire without the help of a screw gauge. Okay, I'll tell you that how to find out the diameter of the wire without the help of the screw gauge. Okay, I'll post the notes, inshallah, these notes which I have shown you just now, and few more notes, inshallah. Okay, so if you have any question, you can ask in my email. Okay, well, thank you so much, and stay blessed, all of you. There are only few seconds remaining. Allah Hafiz. Take care, all of you. Yes, inshallah, I'll post a note. I'll also post some links. Please do watch those links because this will be very helpful for you. You can watch it again to make it for the better understanding. You can watch this also, and you can also